Today we're having a look at Technology Term 1 revision. So ons begin by die tekeninge. So whenever you need to plan something, you need to draw something first. Okay, so it's talking about architects or machinists, people who build things. So ons skryf verskillende tipes tekeninge vir mense wat enigiets ontwerp om te bou. Soos ingenieurs of architecte of so. Okay, so first of all, we've got an artist's drawing. Now, an artist's drawing is just an abstract interpretation. So dit gee nie vir ons 'n 3D in proporsie ding nie, dis maar net 'n abstrakte interpretasie. So like for this one, you can't really see where that thing ends over here. The mountains is not realistic. It's not a realistic drawing of what it's going to look like. Okay, dit is nie, gee nie vir jou 'n 3D realistiese beeld nie, dis 'n abstrakte interpretasie. So that basically just gives you an idea of what you need to build. So then after that we make a perspective drawing. So a perspective drawing is a 3D thing that gives you a true image. So dit ons maak 'n 3D tekening wat vir ons 'n ware beeld gee van presies hoe dit moet lyk wat ons maak. So we start here, that point there, and that point there is called the vanishing point. And that makes this whole thing into perspective. So it's called a perspective drawing because everything is in perspective with each other and it shows you the true size that things are going to be. So dit gee vir jou 'n ware beeld van die perspektief van die tekening en hoe die verskillende dele by mekaar pas. Okay, then we do our planning. So then we do, well, basically like a map. Remember orthografies van aardrykskunde, from geography we had orthographic maps. Orthophotos, that's the one. Okay, so that basically gives us the plan of how the pieces are going to look. So hierdie is die individuele stukke waaruit dit gemaak word en dit gee vir ons 'n tweedimensionele plan van hoe dit gaan lyk. So here we've got a front view, a side view and a plane view, which gives us an idea of what it is going to look like from different sides. Okay, and then you also need to know that the drawings are always measured in millimeters. Okay, that's just a quick recap of the drawings that you need to know. Now let's have a look at forces. So dis die kragte. So 'n krag is basies iets wat iets anders laat beweeg. So force is something that makes an object move. A static force, statiese krag, is something that doesn't move. So there's no change and no movement, so that is static force. Right, now let's look at the different types of forces. Ons kry spanning, tension. And tension is usually when two things move away from each other. So van hier af beweeg hy in daardie rigting en in daardie rigting. So it's usually two directions that moves opposite to each other. Okay, that's tension. Drukkrag is compression. So you compress two things together. Here we've got, for example, this car is compressing this bridge. It's moving down on it. So compression is usually two forces moving in the same direction. Okay, then we've got bending, buigkrag. So that's when something bends. You know what bending looks like. Okay, en dan torsion is wringkrag. Wringkrag is a twist. So if you apply the force to this side, it twists to the other side. Okay, en dit is torsion, wringkrag. En dan kry ons skuifkrag, shear forces, which is two things moving past each other. Okay, wat dit veroorsaak wrywing. So dit is shear forces, it causes friction here in the middle, and it's two things moving past each other. So quickly have a look at this drawing. This is like if you think about tectonic plates moving away from each other is tension. So dit is die twee wat van mekaar af weg beweeg. Okay, en dan kry ons die goed wat na mekaar toe beweeg, so that's compression, and then it forces things out of the way. And then shear forces is soos die tektoniese plate wat langs mekaar beweeg, so that is things that moves side by side, or past each other. Okay, so quickly have a look at these drawings. I'm going to give you a minute to just think about which one is which. Okay, so the first one, this one here, is two things moving away from each other. And now there's a new part in the middle that's forming. So that is tensional forces, like this one, spanning. It moves away from each other. Okay, so hier het ons spanning. It moves away from each other. Okay, here we've got a shear force, a skuifkrag, because it's moving past each other. Dit beweeg verby mekaar. Okay, this one, two things moving towards each other, is compression, drukkrag. Dit druk so van albei kante af. It's compressing it from both sides. And then B here is tension, because it's moving away from each other. And then this one is skuifkrag. It moves past each other. So in two opposite directions. Okay, en dan hier is nog 'n paar prentjies. There's a couple of other ones. Here we've got tension. Dit beweeg na mekaar toe. Here we've got, oh no, this is compression, sorry. Compression. See, it bulges out because these two things presses it from both sides. So this drukkrag. This is tension. It moves away from each other. This is bending, buigkrag. This one here is torsion. Dit twist in die ronde. So I just quickly want to show you here. So this is wringkrag. With this bending, I just quickly want to go back to this picture with bending. You see there's a force here, and then there's two forces from this side here. So on this side and on this side, it's kept upright by a force coming from the bottom. And then here we've got a force coming from the top, wat dit buig. So ons het 'n krag wat afgaan en twee kragte wat aan die kant opgaan, sodat hy net in die middel buig. Okay. So here we've got these two that keeps these two in place, and then a force here which bends it in that direction. En dan hier het ons wringkrag, torsion, and here we've got from two opposite sides, which is skuifkrag, which is shear force. Alright. So just know like which one is which, and think about a couple of examples of each. Okay, now let's look at beams, balke. So what is a beam? A beam is something that carries a load. So dit dra 'n las. The loads must be distributed evenly, so die las moet evenredig versprei word, because otherwise there's a load on the one side that isn't on the other side, and then we get things twisting and torsion and things like that, our structure can collapse. Okay, so ons kry die las moet evenredig versprei wees, sodat die balk en dit wat ons gebou het, wat versterk word deur die balke, nie in mekaar sak nie. So daar nie 'n las op die een kant is en nie op die ander kant nie, en dan kry ons verskillende wringkragte en so aan wat ons struktuur swakker maak. Okay, so a load is basically a force applied from an external force, from an external source. So 'n las is 'n krag wat van 'n eksterne bron afkom. So dit is byvoorbeeld, we've got gravity that pulls things down, and we've got different forces, like we just went through all the forces, and that is, if we're building something, it's called a load. So dit is al die kragte is 'n las. Okay, you just need to be able to identify these beams, which is actually quite simple because it's very descriptive words. An I-beam, E-bulk, is this one here. It looks like an eye. Right? A T-bulk, a T-beam, looks like this. Then an L-beam looks like this. It makes the letter L. And then a HSS beam looks like this. This is blokkie. Okay, in a canal bulk, a channel beam looks like this. It makes a channel. So it's basically half an eye. Alright, those are the ones you need to know. Just know what they're called. You don't need to know specifically what they're used for. Just know the names. Okay, nou kry ons triangulation, wat met driehoeke werk. So we basically have, this is, so triangulation works with triangles to make a structure stronger. Interne kruisspanstukke, internal cross bracing. So it's internal, it's inside the structure. It crosses over each other in order to brace, to make the structure stronger. So dis intern, dis aan die binnekant. Dit kruis mekaar, the beams cross each other. En dit is spanstukke. So dit is dele wat die spanning verlig. Okay, so this kind of thing is internal cross bracing. Okay, now let's look at mass and density. So massa is die hoeveelheid materiaal wat iets bevat. Mass is the amount of material in an object. So basically, if we look at, let's look at a steel bar. Okay, so a stuk staal. Okay, nou kyk ons, how many particles is inside this object? So how tightly are these particles packed? Okay, so the amount of matter is the mass. So hoeveel dele, hoeveel stukkies is binne in hierdie stuk staal, is die hoeveelheid materiaal wat in iets is. Okay, then the density is basically the mass per square unit. So per square centimeter, per square meter, whatever. It's basically, if we're taking 1 square unit, what is the mass of that? So how densely are the particles packed? So ons kyk na die vierkante eenheid, enige eenheid, en dan kyk ons wat is die massa in daardie vierkant. En dan is dit digtheid, dis hoe dig die al die dele saamgepak is. Okay, now let's look at how temperature influences density. So we've got a piece of steel and we heat it up. Okay, so inside this piece of steel we've got the atoms, and the density is how tightly these atoms are packed together. If we heat it up, we give these atoms more energy, which means they can move around more easily, and therefore the density decreases because it expands. So the particles move, the atoms move more, so the density decreases. Okay, so met temperatuur is basies wat ons doen met temperatuur is ons gee energie aan die atome binne in die struktuur. En soos wat ons energie gee, beweeg die atome binne in die stuk staal meer. So dit sit uit. En dus is die digtheid verlaag. Okay, so temperature, as the temperature increases, density decreases. Okay, dan druk, if the pressure increases, the density increases. Because now, think about it as atoms. So when we increased the temperature, we gave them more energy and they started moving around more. And now the pressure squeezes them all together. So now they're closer together, which means the density is higher. So met druk ons letterlik al die atome nader aan mekaar, so dan is die digtheid hoër. Alright, so with this density you can either just learn it off by heart, or you can just think about the atoms and how the atoms behaves in this piece of material that you've got, in the piece of steel or wood or whatever. Alright, so that is the revision for term 1. You can study this for your test and let me know if you've got any questions.